chapter number 4, which is exercise 1, we'll consider the case of one error. We saw in chapter number 3 an example. Now we'll handle this exercise. We have the positions 1 to 15 because we have a bit sequence of 11 bits. We added 4 redundancy bits as we did in chapter number 3. Now our sequence is the following. We have 4 additional bits at position 1, 2, 4, and 8. We did this according to the Hamming scheme. Now, if we send this into the channel, errors may happen. Let us suppose that we have one error. So we send this into the optical fiber, for example, and at the other extremity, we obtained a deformed signal, a received signal which is not identical to the original one, and here we have an error. What is the error? Here, when we do thresholding, we obtain 1 here. It is different from 0 here. But at the receiver, we don't know that we have an error. What should we do? We should blindly apply the Hamming scheme. And if the situation is good, that's fine. If not, we have to correct it. So in a blind way, we do the same scheme. What is the scheme? For 1, I start by 1, jump over 1 and select 1, jump over 1 and select 1 until the end. For position 2, I do the same, start by 2, jump over 2 and select 2. For position 4, I start by 4, select 4, jump over 4 and select another set of 4 bits. For 8, I do the same. Let us do it together. 1, for 2, for 4, for 8. So let us check if the additions are even. So for 1, it is not the case. Let us do it together if you want. So 1 plus 0 is 1, plus 0 is still 1, plus 1 is 2, plus 1 still 2, plus 0, 2, plus 1, 3, plus 0, 3. 3 is not even. So there is a problem with the position number 1. Let us move to position 2. Same situation. Let us do it together if you want. So 1 plus 0 is still 1, plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 0 is 4, plus 1 is 5, plus 0 is 5. So it is odd and not even. So it is bad. For 4, situation is also bad. So the addition is not even. Let us do it together. 0 plus 0 plus 1 is 1, plus 1 is 2, then to jump over 4, and then plus 1 is 3, plus 1 is 4, plus 1 is 5. It's not even. For 8, the situation is good. So we add all the rest, we find 4, which is even. So only 3 positions are bad. We sum up the positions, we find 7. So the error happened at position 7. And that's the case. We correct this situation. So the 1 is converted to 0. Again, why we are able to do so? Because we deal with a binary system. In the binary system, if a bit is not 0, then it is 1. If it is not 1, then it is 0. So it is sufficient for us to locate the error to be able to correct it. If we have a system with 3 values, or with 4 values, or with 10 values, we cannot do correction. Because if we find the location of the error, we cannot decide what is the right value. In the next exercise, we'll see the situation with two errors. However, before that, let me give you one comment about rearrangements. When we arranged the positions from 1 to 15, and we have at positions which are power of 2, we have redundancy bits. Should we send them in the channel, in this case, in this order? We are not obliged. We can do some reshuffling. We can move on these redundancy bit until the end, and we have this. We send this in the channel, and at reception, when we'd like to apply the Hamming scheme, we do the opposite. We re-put the redundancy bit at powers of 2. So the situation is easy. At reception, we perform the inverse rearrangement. So we obtain again this rearrangement, and then we apply the Hamming scheme as usual. So the fact that we send in that way or in the other way is not a problem. The main thing, the receiver should be consistent with the transmitter. In the next chapter, we'll see the situation of two errors.